Artificial intelligence doctor. How to build an agentic doctor using inference reasoning. ChatGPT answer. Building an agentic doctor using inference reasoning involves designing a system that can logically deduce medical insights from user input, leveraging medical knowledge, patient context, and decision-making frameworks. The core idea is to simulate how doctors reason through symptoms to arrive at potential diagnoses and recommendations. Here's a step-by-step approach to achieve this. 1. Define the system's role and scope. Purpose. Provide general health advice, suggest possible diagnoses, or recommend next steps. For example, a system focused on cardiology, primary care, or mental health. Boundaries. Avoid providing definitive diagnoses or prescriptions. Emphasize that it is a support tool and not a substitute for professional advice. 2. Understand inference reasoning framework. Inference reasoning involves three key components. Deductive reasoning. Apply general medical rules to specific symptoms. Example, all fevers above 103 degrees Fahrenheit indicate potential infection. User reports 104 degrees Fahrenheit fever, suggest infection evaluation. Inductive reasoning. Make probabilistic inferences based on observed patterns. Example, most headaches with nausea are migraines. User reports both, suggest migraine as a possibility. Abductive reasoning. Determine the most likely explanation for given symptoms. Example, user has fatigue, weight loss, and frequent urination, most likely cause. Diabetes. 3. Assemble a knowledge base. To enable inference reasoning, you need a comprehensive medical knowledge base. Use structured datasets like SNOMED-CT, ICD-10, or UMLS for symptom diagnosis mappings. Leverage open medical datasets, e.g., MIMIC-3. Integrate guidelines from reputable sources like CDC, WHO, and Mayo Clinic. 4. Choose inference models. Inference reasoning can be implemented using a combination of algorithms and frameworks. 8. Rule-based systems. Create rules to map symptoms to conditions. Example, if chest pain and shortness of breath, then suggest possible heart attack. Tools, drools, prologue, or clips. B. Probabilistic models. Use probabilistic reasoning frameworks like Bayesian networks to evaluate the likelihood of conditions. Example, calculate the probability of pneumonia given symptoms like fever, cough, and elevated heart rate. C. Machine learning models. Use decision trees, random forests, or neural networks for complex pattern recognition. Example, train a model with labeled data, symptoms, diagnosis. Predict probabilities for each diagnosis based on user input. D. Hybrid approaches. Combine rule-based systems with ML models. Use rules for high-risk conditions, e.g., stroke. Use ML for broader differential diagnoses. 5. Design the workflow. Symptom input. Collect detailed information about the user's symptoms, history, and demographics. Use dynamic questioning to gather relevant details. Example, how long have you had this symptom? Does it worsen at night? Inference reasoning. Apply deductive rules for urgent conditions. Example, user reports crushing chest pain in fur. Possible myocardial infarction. Use abductive reasoning for differential diagnoses. Example, fatigue plus joint pain plus rash in fur. Lupus or rheumatoid arthritis. Use inductive reasoning for follow-up questions. Example, user reports headache, ask about light sensitivity to check for migraines. Recommendation generation. Suggest possible conditions with confidence levels. Example, YAML, copy code. Based on your symptoms, 60% probability, migraine. 30% probability, tension headache. 10% probability, sinus infection. Offer next steps. Please consult a doctor for further evaluation. Emotion-sensitive responses. Integrate emotional analysis, e.g., Hume AI, to adapt tone and content based on user stress or anxiety. Example, if the user seems anxious, respond with, I understand this can be concerning. Let's work through this together. 6. Build and implement the system. A. Backend inference logic. Use a Python-based system with libraries like scikit-learn or PyTorch for machine learning, PGMPY for Bayesian reasoning, SymPy for symbolic reasoning, if applicable. B. Conversational frontend. Use conversational agents or chatbots for user interaction, Raza or Dialogflow for text-based interactions, WebRTC or Twilio for voice/video capabilities. C. Integration. Integrate a knowledge graph, e.g., Neo4j, to relate symptoms, conditions, treatments, and risk factors. Use APIs for live symptom checking tools, e.g., Informatica, Medscape. 7. Example workflow. Input. User. I have chest pain that radiates to my left arm. System. Inference reasoning kicks in. Deduction. Chest pain plus left arm radiation, possible myocardial infarction. Recommendation. Please seek immediate medical attention. This could be a serious condition. Input. User. I've been feeling tired for weeks and have a dry mouth. System. Abduction. Fatigue plus dry mouth, possible causes. Dehydration, diabetes. Follow-up questions. Do you feel thirsty often? Do you urinate frequently? 8. Test and iterate. Simulate real-world scenarios to ensure accuracy and empathy. Use feedback loops, e.g., reinforcement learning with human feedback, to improve inference accuracy over time. 9. Deploy safely. Ensure compliance with HIPAA or GDPR for patient data privacy. Add disclaimers. This is not a substitute for medical advice. Tools you'll need. Category. Tools/frameworks. Inference logic. PGMPY, Drools, PyTorch. Knowledge base. Snome CT, Neo4j. Front-end interface. Raza, Dialogflow. Back-end development. Python, Flask, Django. By combining structured knowledge, logical inference, and dynamic reasoning, you can build an agentic doctor that intelligently evaluates user input, infers likely conditions, and provides empathetic, actionable advice. Let me know if you'd like assistance with specific aspects.